Okay, good morning, good afternoon, good evening. My name is Ezra Peisach. I am a software developer and part-time biocurator at RCSB PDB. I am also in charge of maintaining the PDB XMMSIF dictionary here, part of the wwPDB. Today, I'm going to talk about the use of the PDB Beta Archive and the extended PDB IDs, how this affects you now, and what's going to be happening in the future, so you're prepared for it. The Protein Data Bank has served millions of users since 1971, 55 years old and still growing. It's the single global archive of protein and nucleotide experimental structures. It's been an open access digital repository and has currently over 250,000 structures. The PDB, Protein Data Bank, is managed by the Worldwide PDB, which is a partnership between RCS PDB, where I am in the US, PDB Europe, uh, England, in the UK, and PDB Japan since 2003. We are joined by BMRB, which is responsible for the Biomagnetic Resonance Bank at the University of Connecticut, and the Electron Microscopy Data Bank, located also in the UK. And we have an associate member of PDB China, which will someday become a full-time member. The RCSB PDB is responsible for keeping and releasing all the entries that go out to the world in collaboration with our partnership with the other data centers. So let's set you up. For the last 55 years, Protein Data Bank has been using four character identifiers, 4HHB, 3LTQ, very simplistic. As you can see on the right, we have had a large increase in the number of entries per year, releasing on the order of close to 20,000 per year right now. The problem that we have is using this simplistic pattern, which people probably in the 70s thought this would last us forever. We are running out of four-character IDs. So by the end of 2027, we expect to run out of these identifiers. And of course, this activity depends partly on what the what the depositors are submitting to us. Right now, we're anticipating growth and everything, and that's how we came up with this number at the end of 2027. But things could shift around a little bit if people, depending on what research is doing. So the problem is that we need to extend the PDB ID code to more characters than the original four. So we've come up with a scheme where we're going to be using extended PDB ID. So I'll go into more details later. And we have set up a beta archive so you can start testing and use of this now. In July of 2027, July 21st, this beta archive will replace our current production one, and this will have ramifications for anyone who tries to download data from this archive. At the same time, those of you who are still using the legacy PDB format, we will stop being able to support that with these new 12-character extended PDB IDs, and I'll go into that in a little bit. The key message is if you download data programmatically right now from the archive, from the PDB archive, we'd like you to start using extended PDB IDs now and our new directory structure now through the beta archive so that when we switch the archive next year, you're already ahead of the game. You're ready to go. It should be pretty transparent and nothing major will change and break for you. Along the same line, we'd like you to really stop using the PDB legacy PDB format files if you can and adopt to using what I'll refer to as PDBX MMSIF file exchange format now. So the real problem is that the legacy PDB format, which was originally an 80 column, well, mostly 80 column format uh, on essentially punch cards, uh, has some issues. They're fixed column, it's a fixed column format. Sometimes numbers butt up against each other, so with no gaps, so people have had some issues with that. But it's difficult to adopt to evolving science and technology. It was an ASCII-based format where there are remarks which contain metadata, and then we just have the atomic coordinate records. Certain fields cannot be expanded. So we've had a known limit on the number of atoms, number of polymer chains, number of residues, and now the length of the PDB ID. Some of these problems we solved in 2014, and this is where take a little detour for that. So I keep talking about PDBX MMSIF. This is an exchange format designed to be a more flexible format. There's no limit on structure sizes in PDBX MMSIF. It's still a human and machine readable format, and as I'll show you an example in the next slide, it lends itself to a very extensible format that we could keep extending into the future as new experimental methods are developed. It's currently supported by many refinement and visualization software programs. So if you're just a casual user who wants to visualize some files, it'll probably work for a lot of software. This format is also the basis for other dictionaries which control the data format, including ModelSIF, which is used by AlphaFold right now, and IHMSIF, which has to do with integrative and hybrid methods, modeling methods. So becoming familiar with this now is going to be useful for you to the future anyway. On the right-hand side, we put together a user guide with a QR code, and other many ways to get to this, but this sort of gives an idea for those who are familiar a little with what it is, a handbook sort of how to adapt to using such data. So to give you a simple example, PDBX MMSIF was based on the crystallographic interchange format developed by IUCR in I think in the late 70s, for storing their data. Data are arranged in key value pairs or in tables, and allows you to identify what is the data field that you're looking at. So if you are looking at a crystallographic protein, the unit cell for the asymmetric unit, for the unit cell length are recorded with a category name, in this case cell, and then an attribute name, length of A. So this shows you that the unit cell would be 63 by 83 by 53 with alpha, beta, gamma angles, the beta about 99. These data items are controlled by a dictionary. So the dictionary has a description of what each field is supposed to be. The dictionary also indicates data type and restrictions. So for instance, you want integers, you want floating point numbers, you want ranges, you want enumerations. These are all controlled by a dictionary. There's no limit on width of data values, so we're not constrained by the legacy PDB format where things cannot be adapted to be a little wider. And there are parsers available in various programming languages. I also want to point out on the lower right-hand side, we also support multiple values in what we'll call a loop type array, which is sort of a table representation of data which has multiple fields. So for instance, you have multiple authors for an entry. So this is one way of representing it. The advantage of using a dictionary controlled language, uh, controlled format, allows you to then exchange this with others in a fair representation for data interchange. And as I said, ModelSIF is based on the PDBX MMSIF dictionary. So if you have something that could parse a CIF file and then say interpret the atomic coordinates, it'll work for our data, it'll work for AlphaFold data, it'll also work for IHM data. So by using the same common framework, it's extensible and used in various other directions than we originally envisioned. So we have a website which gives general useful information about the MMSIF Exchange Dictionary. So I'm just going to point out, the URL, very obvious, mmsif.wwpdb.org. But inside it, we have things like software resources. So that's a page just dedicated to what software is out there. If you want to know more about the PDBX MMSIF format, we have a page describing it. We have a user guide, which I alluded to earlier on the end, and some other references and some other examples. We also have access to various other dictionaries here, including the ModelSIF, IHMSIF, and other ones that people shared with us. So PDB MMSIF supports large and complex PDB structures. So when I first joined the PDB around 2010, we were treating large structures like a ribosome by splitting it up into multiple files. So a typical ribosome would be in 4 PDB entries because we are limited by the number of chain IDs, one letter per chain. So therefore we had 62 chains when you include capital, lowercase letters, and just a number, digit. So we had entries that were split between two, and then eventually the HIV capsid entry, which was going to be 14 PDB files. This is not very useful to uh, people who want to work on the whole assembly. So in 2014, we switched to making the PBX-MMSIF as the master format. And then we were going to produce compatible files whenever possible. So if you have, so currently, right now, they're about 6% of the archive are only available in PBX-MMSIF format because we cannot produce a PDB formatted file based on limitations on number of chains, number of residues, or number of atoms. Another feature is that since we can extend the dictionary for use by the PBX-MMSIF files, we are able to adapt to developing methodologies. So we have annotations within the PDBX-MMSIF files, which are not available in the PDB formatted files, including information on serial crystallography, branch change carbohydrates, and more, and more. So this forms a more extensible method going forward. And on the right are just some examples of some of the ones that were split apart, and then we put back together again just to put into one entry just to make it easier for analysis. So the first challenge after we created these large structures and we put them out to the public was that in 2021 we knew this for a while, but we recognized that we were going to be running out of three-letter identifiers for residues. So if anyone who's looked at a coordinate file, you know that we use things like AL for alanine ATP, where it is water, HOH, and these are part of what we call our chemical component dictionary. These represent every ligand that shows up in a PDB entry. We recognize that with a 3-character limitation, we were going to run out around 2023. So we extended the description from a 3 characters to 5 characters. And any structure that utilizes one of these new ligand codes cannot be represented in a PDB format file because a PDB format only allows for 3 characters. So since 2023, any new liganded structures are at PBX MMSIF only. And this is one of the first ones that showed up, A1AAF. So in a similar light, we are going to be extending the PDB IDs from 4 characters to 12. So you may say this seems like rather excessive, but there's several things that we want to include this. First of all, we want to make sure that we weren't going to run to a limit in the near future or in the next 10, 20 years. There are automatic methods which are going to look like they're on the verge of producing many, many more structures than we are currently handling right now. And we want to ensure that we are not going to have to go through this process again. We also want to include something to identify that these entries were coming from the protein data bank. So we're including a PDB underscore at the start of it. This allows for data mining, search literature for who's worked with the PDB data. It also avoids situations where we're trying to find entries which have PDB data and you have 3 gigahertz. Well, that looks like a perfectly good PDB ID. So some of the characteristics I'm going to show on the right, you can map the existing PDB IDs. So for HHB, which is our hemoglobin structure by Pruth, would now be PDB underscore 0000 for HHB. But we are going to start issuing new ID codes where you cannot make that mapping. So I just first came up with PDB underscore 1000 for HHB. Now, this has an implication for DOIs, for literature. We are going to continue as long as it looks like a 4-letter PDB ID or PDB underscore 0000. It'll still have the old DOI format. We are going to have a more extended format moving forward for the newly issued IDs, which do not look like that could be represented as a 4-character PDB ID. The important thing is when we run out of 4-letter PDB IDs, any new structure that is produced in the future will not be able to be represented in a legacy PDB file format. The other thing I will point out is we are also using all lowercase in the future. So that's nice. How will this affect you? Well, file contents. First of all, if you're using legacy PDB file format data files, change now. Figure out how to get yourself over the next year, if you haven't done so, to using PDB-XMM format. There will be minimal changes to coordinate files, mainly around what the file names are. So you may be downloading a different file name from the public archive. And there'll be some changes internally within the file. So right now, there's a data block name. The primary ID will change. So there's a field called entry.id. We'll start having extended one. But here's an example right now. This is existing entry 3LTQ. We are in the upper right. We are currently putting out both the shortened PDB ID and the extended PDB ID in different fields. This allows our data out teams to serve these up to the public because they could search for these fields. But in the future, the database code and the extended database accession code will be the same. Now, this use of an extended PDB ID is not terribly new. We may have kept it, we weren't advertising as much as we probably could have, but we have what's called a versioned archive, which we released in 2017. Some of you may have noticed if you look at some of data out websites, like on the lower right, that we have a revision history where we have major and minor versions associated with an entry. And we try to document what are the changes that have been made to an entry so you can make a decision. If you are a consumer of the data through some automatic pipeline, whether you might need to reprocess and redo an analysis based on what the changes are. So minor versions, the last digit, are usually have to do with metadata, while atomic coordinates would be a major version. The versioned archive, uh, which I gave a link on the bottom to, has the latest minor version for every major version. So in the upper right, there's a version 1.2 available, even though versions 1.0, 1.1 existed, we're just not keeping them publicly available in the archive. And then version 2 is the one that's moving forward with any other changes right now. So a citation update is a minor version. Now, if you're trying to monitor that you'd have to figure out if that changed or not. And there's audit information within the file that says what fields really did change. So since 2017, the PDB has allowed for an author to request a replacement of their coordinates after the release of the entry. Say they made a mistake. They had a chirality issue in a ligand, and someone pointed out to them, and they said, "Oh, oops, got to fix that." Well, we want to allow you to always be able to download what was the one that was available when the publication came out. But then we also want them to be able, the authors to be able to revise the entry and make a correction so it's you know so that moving forward, if you had to download an entry, it would have the correct information or the best information that they thought was available. There's another procedure where we could obsolete data and replace it with other ones on a website, but this was a more direct, streamlined one that lined up more with the publications. So as I said, take home is this: we already had this idea of an extended PDB ID in place since 2017. So why should you care? July 21st, 2027, a little over a year from now, the public archive will be placed with what we currently have in place in the beta archive. This new archive will have a similar layout to the version archive, and I'll show you what it looks like in a minute. And as I said, file names and directory names will change. So as I said, we have this beta archive, and now is a good time to start modifying your automatic processing to start using this new archive. When we replace the public archive with the beta archive, you'll still have access to what looks like the beta archive. It'll all look at the same place. So any automatic scripts you develop now will continue to work for a certain time afterwards without having to make any changes into the immediate future. So what do things look like? So on the left, I have what our current archive layout is shown, and on the right is what I'm calling the beta archive. We've lowered things down a level. We've added a wwPDB over here on the right, the wwPDB. We've moved since everything is underneath the wwPDB umbrella, we want to make it clear that they are related. Reference data, which has to do with the chemical component definitions, have moved out from underneath the PDB tree to underneath the wwPDB tree. So this is going to be if you want to what does an alanine look like, or what does this other strange look like, including connectivity information. The rest at the top level, you have a PDB, we have the IHM archive, and EMDB right now here with electron microscopy database. I will point out that we have a list of holdings, which is a series of indexes that tell you what's in the archive, and I'll get to that more on that later. The other major change now is in the current archive, we have divided the structures up into different components. NMR data, the PDB file format, the PDB XMM structure factors, experimental data. These have all been moved to different, they were all in separate subdirectories, and then we'd have a two-letter hash directory, and then we'd have the file. We are now going down just to two-letter hash under entries. Then we have extended PDB ID, and then within that one entry, you have the different subdirectories representing uh, the different components. So assembly information, structures, experimental data, validation reports, putting them all in one place so that you can get one-stop shopping for everything you need for that entry. So here's an example of what that final directory might look like. So I'll just give you the idea. So this is for the entry 3LTQ, which is represented as PDB underscore 0000 3LTQ. This is a screenshot which I took from our beta site, which you can get access to. And you can see pub wwPDB, PDB data entries LT PDB 3LTQ, and then we have the structures, which are the coordinates, experimental data, which will have structure factor files, validation report, and then assembly representations of the files. So how do you get access to these files? Well, there's several mechanisms. Simplest one is just go to files-beta.wwPDB.org in a web browser, and you can walk the tree. I have on the right some examples of where files will be located. So if you want your atomic coordinates, they'll be underneath the structure. They'll be underneath the structures directory. If you want to have X-ray structure factor file, they'd be full path, same idea, experimental data. If you wanted NMR data, it'd also be under the experimental data, just to give you the idea of where everything lives. We also provide access via FTP and rsync at different partner sites, depending on, and I will point out a page later that you could look at. As I said, we've also taken the opportunity to clean up some data that's been there, including removing various indices that we don't believe anyone's using. If for some reason we remove something that you need to function, talk to us. Nothing is set in stone yet, but we really need to know a purpose for putting something back in. So I alluded to holdings files, and these have replaced the index files in our production site right now, even though we're still maintaining the old indices. But they're JSON formatted files which contain inventories of structures, including what are the current structures, what's the last modified dates, when the experimental data updated, what entries were removed. And these could be useful for any type of automated pipeline. Instead of synchronizing the whole PDB archive, you could say, I only want to know what's changed recently, and then pull down that data. I will point out that the EMDB archive also has different file names, but a similar idea for what's in their archive as well. So those are available there as well. And this QR code uh, would give you information that's available on the wwPDB.org website that gives a description of how to download files. But we have a better way. I don't want to deal with these hashes, which letters are the hash characters and figure out how to do that. And we have a service called short links, which avoids the need to understand file system layout. If you just need to periodically download an entry, we have come up with a shorthand. So say I just want the CIF file, go to the files, download PDB-1ABC, and that's it. These are actually also available at the productionfiles.wwPDB.org for not for the extended PDB IDs, but for current entries. And this might make your life a little easier uh, in terms of having access to the files. So you can start using them right now in production for the extended for current PDB IDs. But we, as I said, for the extended PDB IDs, start using the beta site, and here are some examples with it. Again, this QR code, and we're going to hit you over the head with it many times, has a list of how to get access to these files and describes the different formats that you could download. And here I'm giving you an example if you want the ligand definition for ATP. But what happens if you need to download data in bulk? I want to have a copy of the full archive. Well, we provide two options. One is a Python script to download specific file contents. You only care about the coordinate files. You don't want to know about the experimental data. This script is available. That we've written a Python script to allow you to uh, download these efficiently. Or you could use rsync. Rsync is available, a common program. It's a little more tricky if you only want certain file content types where you have to include other things and include other examples. But we have some samples on the description of the beta site download that will show an example of how to do this. So where can you get more information? First of all, the wwPDB.org site has all the information you need if you ever about various activities that we're doing. Uh, So this is the page for the beta archive under archive downloads. It's a pull down menu. Uh, Talks about file locations, uh, how to access data, new sequence and in-sheet data, what the layout looks like, download protocols, how to do it from each site. Each partner may have different services, how the short links and scripts work, and talk about archive snapshots. We also have a list of frequently asked questions and documentation on the extended PDB IDs. Again, the www.pdb.org site, and then they'll be under documentation, then extended PDB IDs. And here's an example of what the page looks like right now, including frequently asked questions. It gives you access to a beginner's guide to PDB structures in PBX 101, PBX MMSIF format from the RCSB PDB 101 website, links to the PBX-MMSIF dictionary. It gives you correspondence between legacy PDB files and PBX-MMSIF. Like, I know what this remark is. How do I find out what that would be equivalent to in PBX-MMSIF? We have that in there, and various software resources. So just to reiterate, if anyone here is from a journal, you've got to deal with the two different DOIs format. I'm sorry about that, but so if it looks like an existing 4-character PDB ID, then it's going to continue doing the same old format, even though it may look like extended PDB 00008Y9M. If it's You still got to use the old format, because the reason for this is that DOIs are persistent and are unchanged to the future. So it would be improper for us to register the extended PDB IDs two different DOIs pointing to the same data, because the old reference is the one that should be used forever. But this means that, well, we have exhausted the 4-character PDB IDs, or people start issuing the new ones. Instead of putting PDB 8Y9M, you're going to be putting the extended PDB ID. So I'm sorry for the confusion, but hopefully this will not be various journals will pick up on this fast enough and won't affect people very much. So my goal is for you guys is to start transitioning to PBX MMSIF now, test your internal pipelines now using the beta archive, test any third-party software you have. We have tried to reach out to various software vendors, ones that do graphical representation. Most of the test cases that we've used have no problem with these extended files. But if there's a problem, let us know or let them know, and we could work with them to help be compatible with PBXMM format. If you have any questions, you could contact us at this email address, info@wwPDB.org. And this is again reiterating, here's what's going to happen. July 21st, 2027, things are going to change. If you download files from the archive, things are going to change. And by 2028, all the PDB IDs, 4-character PDB IDs will expect to be gone, and all you'll have is the new ones. And you better transition, including any software you use, otherwise you'll be left out in the cold. And with this, I'd like to just thank our funders. As I said, I'm from the RCS PDB. Here's our staff. We are funded by the National Science Foundation's NIH, National Department of Energy are our three primary funders. The RCSB PDB lives in multiple locations: University of San Diego, San Francisco, and at Rutgers University in New Jersey.